Hi everyone, this is Mrs. G, and today we are going to learn about transformations of functions. But first, please pause the video and give this warm-up a try. All right, go ahead and check your work here. So this is a review on solving absolute value equations and solving absolute value inequalities, which we reviewed in the last lesson. So if you need a little more review, go back and watch that video for 1.3 again. Okay, so today we are going to start learning about one of the most important concepts that you will learn in Algebra 2, and that's called transformations. So transformations are changes to the size, shape, position, or orientation of your graph. So there are a few rules that we're going to learn about today that will apply to every single type of function that we cover this year. So learning the rules at first can feel a little bit tough and maybe it takes a while for them to sink in, but once you know the rules, you can apply them to every type of function and it's always the same rules. So once you know it, it becomes a lot easier and we're going to use it in every single chapter that we cover this year. So there are three main types of transformations. Transformation is just the general word for the change. The first type is called a translation. And it's a transformation that shifts your graph. So translation is really just a shift. And you can shift horizontally, which is left or right, or vertically, which is up or down. But in our class, we're going to use the word translation instead of shift. So we're going to try to use the formal math language for these transformations. The second change is called a stretch or shrink. So this is something that transforms your graph by multiplying your x or y value. And it essentially keeps your graph in the same general position, so you're not shifting it or flipping it upside down. But it's like if you put your fingers on the top and bottom of your graph and you pull them apart or push them together, or if you put your fingers on the sides of your graph and you pull them apart or squish them together. That would be a horizontal or vertical stretch or shrink. And again, it's really just a multiplier to your x or y value. And the last type of transformation is a reflection. So this is a transformation that flips a graph over a line, and we are going to do reflections over the x-axis that look like this, so it's actually flipping vertically, or transformations about the y-axis, so a side-to-side reflection. So these are the types of transformations we need to learn how to recognize in an equation, but also how to recognize them in a graph or apply them to a graph. So we're going to start by looking at just a general function form of our transformations. So let's start with translations. So there are two, again, types of translations are shifts, and you can do it vertically, meaning up or down, or horizontally. So the operation that you use for translations is addition or subtraction. This is if you add or subtract. So if you see addition or subtraction in your function, it's going to be some type of translation. Then to figure out what type, you have to ask yourself, where is that addition or subtraction happening? So if you compare these two, the horizontal and the vertical, if you're adding or subtracting outside of your function, so not specifically with x, but after, it's going to be a vertical translation. It's going to affect our y value. And if you add k, it shifts our graph up. And if you subtract k, it shifts our graph down, which to me feels pretty intuitive. Now, if you notice that the addition or subtraction is specifically grouped with x, that's going to be a horizontal translation because horizontal things affect the x value. Now here you need to be careful. Anything horizontal is kind of strange when it comes to transformations. So if you actually see x minus h, it's actually going to translate your graph to the right. And if you see x plus h, it's actually going to go to the left. So I like to say that it actually goes in the opposite direction than you would think. So that is a little bit tricky, but once you know to look out for it, it's not too hard. Now let's look at the next type of transformation. These are the stretches or shrinks. So again, we have vertical ones or horizontal ones. So if you look at the operation that's happening here, I say a times f of x or f of b times x. So if you see multiplication as your operation, if you are multiplying by something, it is going to be a vertical or horizontal stretch or shrink. That's the type of transformation. Now we have to decide what type, and that depends on where you're multiplying. If you're multiplying out front, it affects the y values, which means it's a vertical stretch or shrink. Now, if that a value is bigger than 1, we call it a vertical stretch by a factor of a, and if the a value is between 0 and 1, we call it a vertical shrink by a factor of a. You'll notice that the a value is always positive. If there is a negative, that's actually a separate type of reflection or transformation, which we'll talk about in a second. It's a reflection. Now here you'll see that I'm multiplying specifically in my parentheses to the x. So since I'm doing it specifically to the x, this is a horizontal stretch or shrink. Now again, all the horizontal stuff is a little bit tricky. Here, if your b value is between 0 and 1, we actually call it a horizontal stretch. Now here's the tricky thing. The number you see in the equation is not the stretch or shrink factor. The stretch or shrink factor is actually the reciprocal of that. So if you see a b here, like times b, the factor is actually 1 over b. Okay, so that's really tricky. You have to remember it's a reciprocal. So if you have a number between 0 and 1 and you take the reciprocal of that, it's going to be bigger than 1, making it a stretch. And if this b value is bigger than 1 and you take the reciprocal of that, you'll get a number less than 1, so it's a shrink. So you have to look at the factor. So you have to write down what is your stretch or shrink factor, and then you can decide if it is in fact a stretch or a shrink. So if the factor is bigger than 1, it's a stretch. If the factor is less than 1, it's a shrink. And then the last type of transformation is a reflection, and that's if you multiply by -1. So times -1 to your function, and then you have to decide what type of reflection it is, and that depends where you multiply. If you multiply out front, it's always going to be a reflection over the x-axis, and it's actually a vertical reflection. Even though we say the word x-axis, if you're going over the x-axis, you're going top to bottom, making it vertical. And if you see the negative on the inside, specifically done to x, that should be a horizontal reflection, which would be side to side. A side-to-side reflection is actually over the y-axis. And there you go. So for each of these things, you can ask yourself, what operation do I have? And that will tell you what type of transformation. And then you'll ask yourself, where am I doing that operation? Is it inside my function or outside my function? And that will tell you if it's going to be horizontal or vertical. All right, first we're going to practice just describing the transformations we see here in reference to the parent function f of x. So a parent function is a function with no changes. Okay, so here, first thing I see is a plus sign. So this is telling me that it's some type of translation. It's specifically grouped with x inside parentheses, so I know this is going to be a horizontal translation. Now remember, the horizontal translations move in the opposite direction that you think. So I know it says +2, but this is actually going to shift our graph to the left 2 units. Now let's look at part B. Here I see I'm multiplying my graph by -1. So I know right off the bat it's some type of reflection. And since it's on the outside, it's a vertical reflection, which means a reflection over the x-axis. All right, for part C, I see that I'm multiplying my graph by something, which tells me it's a stretch or shrink. Since I'm multiplying on the outside of my function, I know it's vertical. So it's a vertical. Now I need to know if it's a stretch or shrink. Remember, for vertical stretches or shrinks, whatever you see here is the stretch or shrink factor. So my stretch or shrink factor is 1/2. And since that's less than 1, we call it a shrink. So this is a vertical shrink by a factor of 1/2. And yes, you do need to write the stretch or shrink factor. All right, let's look at this next one. I'm adding or subtracting, so I know it's a translation. Now here, I'm doing it outside of my function. You'll see it's outside of the parentheses, so I know this is a vertical translation, and these types go in the exact direction that you see. If you add 3 outside, it's going to shift your graph up 3. So the opposite stuff only happens for horizontal translation. All right, this next one's probably the trickiest one. I'll put a little star by it. It's kind of a challenge problem. So remember, I'm multiplying, so it's a stretch or shrink, but it's inside, so I know it's horizontal. So I know it's horizontal, I know it's a stretch or shrink, but I want to know what the factor is. And remember, for a horizontal stretch or shrink, the factor is actually a reciprocal of what you see. So if the equation has 1 over 3, the factor is the reciprocal of that, which is 3. And since my stretch or shrink factor is bigger than 1, this is actually a horizontal stretch. So that's definitely a tricky one. We know it's horizontal because it's inside the parentheses. We know it's a stretch or shrink because I'm multiplying, but we have to know what that factor is before we decide if it is a stretch or a shrink. All right, for part F, our last one here, I say I'm multiplying by -1, so I know it's a reflection. It's being done specifically to x, making it horizontal. Horizontal reflections reflect over the y-axis. So if you multiply the x, you actually reflect over the y-axis. And there you go. All right, go ahead and pause the video and see if you can give these a try on your own. All right, go ahead and check your work here. This one should be a vertical translation down 7. This should be a vertical stretch by a factor of 3. Here we have a horizontal translation to the right 4. Remember, it moves in the opposite direction. This one's the trickiest one. I see that the number in my equation or my function is a 2, so I know that the factor is the reciprocal of that, which is 1/2. Since my stretch or shrink factor is less than 1, it becomes a shrink. So horizontal shrink by a factor of 1/2. All right, so now we're going to practice kind of doing the opposite. We're going to be given the transformations in words, and we're going to write them into a function. So this says create a function g of x that transforms f of x in the following ways. So I'm going to start by saying g of x equals, so that's my new function. Now, here I have a horizontal translation, right 3, and I have a vertical translation, up 7. So I know I'm just doing addition and subtraction for this. So the horizontal translation is going to go inside my parentheses. So I have x, and I know if I want to go to the right 3, I actually have to subtract 3. And then the vertical translation, up 7, I'm going to add 7 outside of my parentheses. And that's it. All right, let's try this next one. So I'm going to say g of x equals, that's my new function. I have a vertical stretch by a factor of 4 over 3 and a reflection over the y-axis. So this one, a vertical stretch, we multiply out front, and whatever the factor is what I multiply by. It's very straightforward. Now, a reflection over the y-axis, remember, we multiply the x by -1. So that's a horizontal reflection. This last one, we have a reflection over the x-axis, horizontal stretch by a factor of 2, and a vertical translation down 5. Well, lots of stuff going on here. So first, a reflection over the x-axis puts a negative out front because it's a vertical reflection. And then we have a horizontal stretch by a factor of 2. So I know it's going to be multiplied to my x value, but remember, for a horizontal stretch, the stretch factor is actually the reciprocal of what we see in the function. So if the factor is 2, what I'm going to write in my equation is 1/2. And then we have that vertical translation down 5, so that goes outside of my function, and I'm just going to subtract 5. So there you have it. So this is writing in a function given transformations. All right, go ahead and pause the video and give these three a try on your own. All right, go ahead and check your work here. The stretch and the reflection are both verticals. They go out front. And remember, if I want to go left one, I actually add one to x. So I do the opposite there. Part B is tricky. Since the horizontal factor is 1/2, what I write in my function should be the reciprocal of that. And then I do +4 on the outside for the vertical translation. And then here, reflection over the y-axis is horizontal, side to side. So the negative goes inside. The vertical stretch goes out front, and the -6 goes outside. All right, so now instead of just doing general function form, I'm actually going to transform a type of function that we've been working with, which is our absolute value function. So this is our parent function, and we're going to transform it in these ways and call it f of x. So instead of putting it in function form, again, I'm going to use absolute values. Anything horizontal goes inside the absolute values. Anything vertical goes outside of them. So I have f of x equals, so here I have a vertical stretch by a factor of 5, so that means I multiply by 5 outside, and then I have the horizontal translation left 3. So I know that's going to go inside my absolute values because it's horizontal, and if I want to go left 3, I'm actually going to add 3 to the x value, and that's it. And then let's try this one. So I have f of x equals, I have a reflection over the x-axis, which is vertical, it goes out front. Horizontal shrink by a factor of 2/3 and a vertical translation up 4. So for the reflection, I can put that out front. For the horizontal shrink, remember I have to flip it to put it in the formula or in the equation. So it's actually 3/2x. All of that's happening inside the absolute values because it's horizontal. Now this vertical translation will happen outside of the absolute values, and I'll just add 4. And there you have it. All right, go ahead and pause the video and give this one a try on your own. All right, go ahead and check your work here. Make sure the 1/2 is out front. Inside for the horizontal translation, make sure you have -8, and we have to do the opposite of what you see. And then the -5 for the vertical translation should be outside of your absolute value. All right, so now we're going to practice transforming graphs of functions. And we're going to still use our same transformation rules, but we're just going to apply those rules to our specific coordinates. So if you have a vertical stretch or shrink, what should you do to your coordinates? Well, we know that the operation is multiply, so we're going to multiply to the y values. Anything vertical, we do to the y values. And for a horizontal stretch or shrink, we're going to multiply to the x values. You just have to make sure for this one that we use the reciprocal for that stretch or shrink factor. So whatever the factor is, that's what we multiply by. For a vertical translation, we're going to add or subtract, and we're going to do that to the y values of our coordinates because it's vertical. And for a horizontal translation, we add or subtract to the x values. And then for a reflection over the x-axis, we actually are going to multiply the y values by -1 because a reflection over the x-axis actually is a vertical reflection. It's going top to bottom or vice versa. And for a reflection over the y-axis, we're going to multiply the x values by -1. And so we can do this to pictures of graphs we already have to graph a new function that's been transformed. Now, before we practice doing this to a graph, we're just going to practice doing it to a single coordinate, and then we'll do it to the full graph. So the coordinate that we're starting with for all of these is the coordinate -2, 6. and then we have to decide how should I change this coordinate according to these rules. So I like to write the coordinate here below each one. Now, I'm always going to do things that involve multiplication first. So here I see that vertical stretch by a factor of 3. So since it's a vertical stretch, I know it affects my y value. So I'm going to multiply my y value by -3. So that brings me to -218. And then this I see as a horizontal change. Now I know it says +4, but remember we always have to do opposite for it. So and it's actually going to go to the left 4. So if I want to move this coordinate to the left 4, I'm actually going to subtract 4 from the x values because it's horizontal. So my transformed coordinate is going to be -6, 18. So especially when we're first learning with transformations, I think it's best to just do one transformation at a time. So first I multiplied my y values by 3, and then I subtracted 4 from my x values. All right, let's try this next one. So I'm starting with -2,6. First I see this negative out front. Since it's out front, it's going to affect the y value. So I'm going to multiply my y value by -1, and that reflected my coordinate. And then I see that we actually have a horizontal shrink by a factor of 1/2. So I'm going to multiply my x value by 1/2. So now I'm at -1, -6. And then the last thing I need to do is this vertical translation up 3. So I'm actually going to add 3 to my y value. So -1, -3. And that would be my transformed coordinate. All right, let's try this one. So I have -2,6 as my starting coordinate. I have a vertical shrink by a factor of 1/2. So I multiply my y value by 1/2. This is a reflection over the y-axis, which is horizontal. It's affecting x. So I'm going to multiply my x value by -1. And then I have a vertical translation down 2. So I'm going to subtract 2 from my x value. So I have 2, 1 as my transformed coordinate. All right, last, I only have addition or subtraction, so it doesn't matter which one you do first. As long as you're doing multiplication first, after that it doesn't matter. So here, this is a horizontal translation to the right 5. So I know this says -5, but I have to do the opposite and actually add 5 to my x value. So 3, 6, and then I have a vertical translation up 1, so I add 1 to my y value. So 3, 7. So using transformations, we were able to transform a specific coordinate of our graph to find the coordinate of a new function. All right, go ahead and pause the video and give this one a try on your own. All right, check your work here. Multiply your y value by 1/2, add 1 to your x value. And then for the second one, multiply your y value by -1, multiply your x value by 2, the reciprocal of your b value, and subtract 2 from your y value. Okay, now that we know how to transform specific points, we can now transform a graph. And really what I'm going to do is I'm going to take specific points from our graph, like nice clear points, and I'm going to apply those same rules. So here's f of x, and I want to do a new function, which is f of x minus 2. So this is a vertical translation down 2. So we would subtract 2 from the y's. So I'm going to take a point that I see here, and I'm not going to change the x value. I'm just going to take the y value, and I'm going to subtract 2. So then the 4 becomes a 2. Here's another point that I can see, so I'm going to subtract 2 from the y value. And then maybe I'll take like this point, just pick nice clear points. I'm going to subtract 2, and then maybe I'll take this point, and I'm going to subtract 2 from the y value. And then I'm just going to connect them in the same order that they were connected before, and this is my transformed graph. And you can see that it has just been shifted down 2. Now let's try this one. We're going to do f of x plus 3. So I'm actually going to subtract 3 from the x values. This is a horizontal translation, left 3. So again, pick a couple nice coordinates. Maybe I'll pick this one, and I'm going to move the x values to the left 3. So 1, 2, 3. I can go from this coordinate, 1, 2, 3. I'll take this coordinate and go 1, 2, 3. And maybe I'll pick one more coordinate here again, and I'll just go 1, 2, 3. And then I connect my dots in the same consecutive order, the same relative order. And there you go. You can see our graph has been shifted over to the left 3. All right, let's try this one. This one's a vertical shrink by a factor of 1/2. So I'm actually going to take my y values and I'm going to cut them in half. So like this y value is 4. If I multiply that by 1/2, it becomes 2. Let's take this y value. This y value is 2. If I multiply that by 1/2, it becomes a 1. This y value is -2. If I multiply that by 1/2, it becomes -1. If I take any y value that's 0, that should stay the same because 0 times 1/2 is still 0. So now I can connect my dots like this. And you can see that it does kind of look like I put my hands on the top and bottom of the graph and just move them towards each other. It's like I'm squishing it vertically. But all of my y values were simply cut in half. All right, so now let's try to do 2 changes at once. So here I have a reflection over the y-axis. So I'm going to reflect over the y-axis. And then I'm going to shift up 1 by adding 1 to the y values. So let's take each point and do those at the same time. Well, first I'm going to do the reflection because it has multiplication. Then I'm going to go up 1. So if I reflect over the y-axis, that goes from here to here. And then I'm going to go up 1 from there. So my transform point would be here. All right, let's transform this point next. And then I'm going to connect the 2 to make sure they connect in the right order. So if I reflect it over the y-axis, it goes from 2 to the right to 2 to the left. And then from there, I shift up 1. So my next coordinate will be here. It's going to connect this to this. Maybe the next coordinate, I'll pick this coordinate. So I'm going to reflect it. So it goes 4 units from the right to 4 units to the left. And then I shift up 1. So it goes here. And then I'm going to pick something over here, which would come after this graph. So I'm going to pick this point, -3, 0. If I reflect it over the y-axis and then shift it up 1, I have a point here. And then I can connect like that. So here you can see that it was reflected and then shifted. Just make sure you're always doing reflections first. So I reflected, then shifted. I took this one, I reflected and shifted. I took this one, reflected and shifted. And then I took this coordinate and I reflected and shifted. And you can pick whichever coordinates you want. Just try to pick nice coordinates and ones from all pieces of your graph. All right, let's try another one together. Here I have a different graph. So let's look at the transformation and see what our graph should be doing. This one should be shifting to the right 2. Remember, it's the opposite of what you see. So I'm going to pick some nice coordinates, like maybe these, and I'm going to shift them all to the right 2. So 1, 2, 1, 2, 1, 2, and 1, 2. And I'm just going to make sure I connect them in the same order. And then my graph would go something like that. Maybe I'll just shift this one to the right too as well. I'll add some extra tick marks. All right, this one, we know from our transformations that it would reflect over the x-axis. It's a vertical reflection. So same thing, let's reflect these 5 coordinates. So instead of being 2 above the x-axis, I'm going to go 2 below. So here, if it's on the x-axis, it stays the same. 3 above goes 3 below. Here, 3 below goes to 3 above. And then 2 below goes to 2 above. And there you go. All right, here I'm going to do 2 things. I'm going to do a vertical shrink by 1/3. And then shift up 1. So my y values are going to be divided by 3, and then I'm going to shift them up 1 after. So like this y value was at 3. If I multiply that by 1/3, it brings me to 1, and then from there I shifted up 1. So my coordinate is here. This y value is -3. Multiplying it by 1/3 gives me -1, and then I shifted up 1 from there. Here, this y value is 0, shrinking it stays 0, and then I go up 1. This value was 2. Multiplying it by 1/3 gives me about 2/3, and then up 1. So I'm just going to kind of estimate where that is. And here, 2 becomes 2/3, and then I shift that up 1 to around here. And then I just need to make sure I connect my dots in the right order. And the last one, here I have a horizontal shrink by 1/3, and I'm going to shift up 2. So that means that all of my x values are going to be divided by 3, and then I shift them up 2. So this x value is -3, and then if I multiply that by 1/3, it becomes -1, and then I shift up 2. This x value is 0, so the shrink doesn't change it, and then I go up 2. This x value is -3, or +3, so it becomes +1, and then I go up 2. Let's see, and then we can kind of estimate for these other ones. This is 5, and so it becomes 5/3, and then we go up 2, so somewhere around here. And this one's -5, so it becomes -5/3, and then up 2. And then we just connect our dots. So it looks like that. So you can see it looks like I put my hands on both sides and move them together, creating that horizontal shrink. Okay, here's the last few tries, so please pause the video and give it a shot. All right, go ahead and check here. So this will just simply shift our graph down 4. So all of my coordinates, I just moved down 4 units. This one is a vertical stretch by 2, so all of my y values were doubled. This one's a horizontal shrink by 1/2, so all of my x values were cut in half. So this 4 became a 2, -4 became -2, 4 became 2. And then this one shifts our graph to the right 3. So every coordinate was simply shifted to the right 3. So understanding how these transformations in your equations affect your graph can be really useful in the process of graphing. All right, that is all for today's lesson. Thank you so much for watching.